Hey guys, welcome back to Maths from My Desk. I'll be doing now question 2 of the 2024 AP Calculus AB FRQ. So a particle is moving along the x-axis so that its velocity at time t is greater than or equal to 0 is given by this equation over here. And there's one time t equals t sub r in the interval from 0 to 2 when the particle is at rest, so it's not moving. And we're going to find this t sub r, and for this interval, is the particle moving to the right or to the left? Okay, so what the particle being at rest means that the velocity vector has to equal to 0. So essentially we graph the velocity vector and we found when t is equal to, and if we take a look at our graph, we find 1.426. So that is the first part of the question. Now, is the particle moving to the right or to the left? So if the particle is moving to the right, that would mean that the velocity vector is positive, so it's greater than 0. And is that the case in this interval? And the answer is yes, because thus moving to the right. That's what we can say. And if I want to be a little more specific, I lost my what I said in question 1. But if I wanted to be more specific, I could say during this interval, let me present. I could have said in this interval over here. Now let's move on to question B. So when I find the acceleration of the particle at time t equals 1.5, I want to show the setup of the calculations, and I want to know if the speed of the particle is increasing or decreasing at t equals 1.5. So we know that acceleration is equal to the derivative of velocity with respect to time. So we want to calculate velocity. We want to calculate the derivative. We want to calculate the derivative of velocity at 1.5, and so this is equal to d over dt of the natural log of t squared minus 4t plus 5 at t. Sorry, minus 0.2. I forgot that one. T at t is equal to 1.5. I went ahead and did that in my calculator, and I found that this is equal to negative 0.999, or we can say negative 1. And is the speed of the particle increasing or decreasing? It is decreasing because v prime of t is less than 0, and this is what I would do. So third question, the position of the particle at time t is x of t, and its position at time t equals 1 is x of 1 is negative 3, and we're going to find the position of the particle. Alright, so the way we would go ahead and find the position is by integrating the velocity. So we integrate, I'll say from 1 to 4, velocity vector, dt, which is equal to the integral from 1 to 4 of x prime of t dt, which is x of 4 minus x of 1. And that equals, I went ahead and plugged that into my calculator, and it gives me 0.197, and x of 1 is negative 3. So I get x of 4 plus 3 is equal to 0.197. So all I have to do is subtract 3 from both sides, and I end up finding that the answer is x of 4 is equal to negative 2.803. Now we move on to the last question. Find the total distance traveled by the particle over the interval 1 is less than or equal to t is less than or equal to 4, and show the setup for your calculations. So in order to do that, we would integrate the absolute value of the velocity vector, because we know speed is simply the magnitude of velocity. So we integrate from 1 to 4 the absolute value of velocity with respect to time, and I get an answer of 0.958. So that is it for question 2.